Voice is the original UI. Yes, but I also think that it is the future of UI. We are seeing a phenomenon where most software is now adding voice support along with text inputs. If you want to add voice support to your apps or in general gain an understanding of how speech models work, I think this video will be very useful for you. Hello everyone, welcome to Data Creator AI, and in this video we will discuss Voxtral, the speech model by Mistral. Now, when we say audio, usually OpenAI's Whisper comes to mind, but there are many other cheaper and better alternatives out there, and Voxtral is one of them. It is specifically designed for automatic speech recognition and speech understanding. This model, it comes in two sizes. One is the 24 billion model and the other one is the 3 billion model. So the larger model, it has a 32K context window and it can handle audio up to 30 minutes for transcription or 40 minutes for understanding. So if you see in this graph, these models, they score very well compared to more expensive models like Whisper or Scribe. The pricing starts at $0.01 per minute, which is basically around 5 to 10 rupees in Indian currency. And one more advantage is that these models are multilingual and they support all these languages, including Hindi, which is an Indian language. If you scroll a bit down, we can see a demo of how Hindi mixed with English is transcribed.
देखो यार, वो क्लाइंट मीटिंग आज पोस्टपोन करनी पड़ेगी क्योंकि मेरा कैलेंडर एकदम फुल है। तुम प्लीज़ उन्हें मेल करके रीस्केड्यूल कर लो और वो अपडेटेड एजेंडा भी शेयर कर देना अर्जेंटली, ठीक है?
So we've seen how Hindi mixed with English has been transcribed here in this example. This could be very useful for applications like making meeting notes and transcribing videos because this is how conversations usually pan out in the real world. In our API example as well, we will see how it works for Hindi and English audios. So coming to the benchmarks for speech transcription and also audio understanding, these models surpass the performance of Whisper, which is the best open source speech transcription model. These models, they are predominantly for audio, but they also have their usual LLM text capabilities, like you give text as input and text as output, and they can also be used in the place of Ministral or Mixtral. Now, before we go into the testing of the API, let's briefly discuss how audio models usually work and how they are developed. The internal architecture of the Voxtral model is mentioned in detail in their research paper, which we will now see. So, the Voxtral model is based on the transformer architecture and it has three components: an encoder, an adapter, and also a language decoder. So let's see how this process works. The audio is first converted into a MEL spectrogram. A MEL spectrogram is basically a digitized form of the audio that can be fed into an encoder. Models can't directly work with raw waveforms efficiently. So the spectrogram, it becomes the structured input that the audio encoder can actually learn some embeddings from. So if you want more information on how audio is converted into these spectrograms, you can refer to this blog on Hugging Face. And there are also some code snippets in Python where you can see the frequency spectrum and also the MEL spectrogram. I will add the links in the description. So coming back to the architecture, so once the audio is first converted into a spectrogram and then it is divided into chunks of 30 seconds and then it is padded because the audio encoder, which is again a Whisper model encoder, it accepts the input this way. It accepts input in 30-second chunks. So if, let's say for example, if a chunk is not 30 seconds, a small padding is added in order to make it to the 30 seconds. Now, the audio encoder, it receives these 30-second chunks. It converts them into audio embeddings, and then this audio adapter, it reduces the dimensions of these embeddings for efficiency. So if you go down in this paper, they mention that a 30-minute audio at 50 hertz frequency, it could go up to 90,000 tokens, which is very high, and it will also be expensive and make the inference low. So in order to mitigate this, they have reduced the frequency to 12.5 hertz. And after doing this, the 40-minute audio came up to a context length of 32K tokens, which is more manageable. Now, let's come back to the architecture. These reduced audio embeddings, along with the text embeddings that come from the question, they are fed into a language decoder, which is again a typical LLM like a Mistral large or Mistral small, which will then give you the transcription, or it will answer the question that the user has asked. And so this is basically how the architecture of this model looks like. So one interesting aspect of this paper was also the role of synthetic data in the development of these models. So once the pre-training, this is the pre-training stage. So once the pre-training is done, the LLM is fine-tuned with synthetic data pairs of questions and answers, which were generated using a long audio and their corresponding transcripts. So you can see that the tasks, the speech understanding tasks, are divided into two different types, and both of them rely on synthetic data. So each transcript and its corresponding audio are fed into a model like Mistral Large, which then generates different possible questions and answers from those transcripts. So this data, it shows the model how to answer various questions from the audio. And so this is a concrete demonstration that synthetic data is not just a shortcut, but it is a multiplier that can accelerate model development. And it is also a proof that synthetic data can be successfully leveraged to build production grade models. And even big AI companies like Mistral are using it to develop their systems. Finally, for alignment, direct preference optimization is used. And for the benchmarks, the macro average word error rate is considered as the metric. So word error rate, it tells how many matches the transcribed text has with the actual text. So this is based again on Levenstein distance, if you've heard of it, which is used for obtaining text similarity. And this word error rate is based on Levenstein distance, and it is one of the basic metrics to measure the accuracy of speech recognition systems. As you can see, the Voxtral Mini Transcribe, it performs almost as well as much larger and more expensive models like Whisper. Now that we have a basic theoretical understanding, now let us see how the API works. Now let us go through the official documentation and see how the API can be used for transcription and speech understanding. So if you see, there are these three models that can be used with audio related tasks. One is the Voxtral Small, Voxtral Mini, and Voxtral Mini Transcribe. And there are two ways to perform audio tasks using Mistral API. We will see them now. First, let's start with using audio with instruction following models. So you provide the model name, and then you use the general chat API in order to provide the input audio and also the questions. So the type of the content here is input audio, and this is the base64 version of the audio that you have provided. So this is the method to provide the file based on a path, or you can also pass the audio through a URL. If there's a public URL, you can just, instead of starting with opening the file, you can just provide the URL here. Or you can also upload your audio file to Mistral. Like, let's say if you're repeatedly using a file, then it's better to upload the file to Mistral and then use it whenever you want. So in this case, what you do is what you can do is first you use the API, the files API, and then upload the file. You'll get a signed URL, and that signed URL you can mention in the input audio. And here the question is what is in this file, but you can ask any question from the audio. Let's say pointing to a certain section or some other important details or numbers. So this is one method of using audio. This is for speech understanding. As you can see that you give the audio as the input and then you ask questions based on it, or you can ask to summarize it. Now let us see some examples of what else you can do. So this is the chat where you can transcribe the audios. So this is also option to ask the model what exactly is in this file. It says it contains music. So you can ask what the conversation is about, or if there is a conversation, or if this is just a song or music. And there is also an option to compare the speakers and get some sentiment analysis out of the audio. If you can see here, this audio is the first audio is the speech by Obama. And the second audio is basically a weather forecast by some person in Barcelona. So when you play these two audios and you can ask the model to determine which audio is talking about what topic and which speaker do you prefer and how are they different. So the assistant gives the answer saying that the first speaker is delivering a farewell address and the second speaker is less engaging and it's more about factual information rather than an emotional speech. These are some things you can do with the Mistral audio API. Then the next part is transcription of the audio. So for this, you can directly use the client audio API where you can use this transcriptions class to get the transcription from the given URL. So here there's a file which is again points to the speech by Obama. You can also see the transcription with timestamps, as in like from this second to this second, this is what he said. We will see it in the example anyway. But there is also an option to get each audio segments from the speech. So even for this, you can directly use the Voxtral Mini latest model, and then you can do it. You can do the transcriptions, and the language here is auto detected from the audio, or you can also mention the language as English or Hindi. But when you want to mention segments, then you can't mention the language. So it's either this or that. You can't do both at the same time. So these are some of the things that you can do with Mistral Audio. And for now, for transcription, you can upload up to 15 minutes, which is actually like really high. And if you want longer audio files, you can divide your entire audio into smaller segments and transcribe it, or you can increase the playback speed. So this is an overview of the chat API documentation. So there are two kinds of tasks as we've seen, speech understanding and transcription. Now let us see this in action and see the outputs and how it works in code. So this is the notebook I've prepared. This is a very basic notebook for understanding the API. So let's just install Mistral. And then we import all the necessary libraries, and this is just for formatting. And then here we initiate the client with this model. It's the same code as what we saw in the API documentation. And then let's see the transcription response. So here I'm using only the transcription and I want to see the timestamp granularities. And this is again, I've taken this from the documents. This is the speech by Obama. And now let's print out the speech and see. So this is kind of a longer speech, and so if you see, all the entire speech has been completely transcribed. So in the speech, basically he's giving a farewell speech and talking about all the different kinds of work he's done in his presidential years. And then here we can print the transcription response granularities, that is the segments. If you see, let's execute this again. So each transcription segment is divided into different chunks. So if you start in this chunk, this is the text. And where does it start? It starts at 0.8 seconds and ends at 6.2 seconds. And the type is transcription segment. And these segments are provided for the entire audio, for the entire speech. So if you can see here, it's until the end. Start is at this seconds and end is at these seconds. So you have all the transcription segments. The main advantage of obtaining the transcription segments like this is that it can help in providing subtitles in another language for subtitling, and also you can use these transcription segments for searching through a video, like let's say searching for a phrase in a particular video and you directly want to jump to that a specific segment in the audio or video. So these things can be done with these timestamp granularities. Now we have seen how this transcription works. Now let us also see how it works for an audio in Hindi. Like we have discussed earlier in the video that many languages are supported through this Voxtral model, and Hindi is also one of them. So this is an Hindi audio which I have recorded. It is a very short snippet on the importance of protecting our environment. And let's just play like for a few seconds and see what this is.
पर्यावरण वो सब कुछ है जो हमारे आसपास है। हवा, पानी, मिट्टी, पेड़ पौधे और जानवर, ये सभी मिलकर हमारी ज़िंदगी को सुरक्षित और आरामदायक बनाते हैं। अगर हवा साफ ना हो, पानी गंदा हो जाए या जंगल कम हो जाए तो हमारा जीवन बहुत मुश्किल हो जाता है। इसलिए पर्यावरण का ध्यान रखना ज़रूरी है।
Yeah, so it's basically talking about how it is important to protect the environment. Now, just like how we saw in the API, we will read the file and convert it into base64. Now this base64 string, we will just provide it as input audio. And first, let's ask the model to transcribe this content in the audio to English. So if you see, this is the speech understanding task, but we are using it for transcribing. We can also ask questions to it instead of this text. You can also place some questions like what is in this audio, or what is this audio about, or what does this audio say about protecting the environment, or any other questions like that. So let's see the output. Yeah. So if you see, it has transcribed the audio and it printed the output in English. So the original audio was in Hindi, but now we have a transcription in English. So it's basically the same content that you can protect the environment by doing small things like saving water or using electricity only when needed and things like that. Now let's see how it works with Hindi. So I will use the same prompt. I will just change the language to Hindi. So let's execute this again. So you can see that now we have the entire transcribed audio in Hindi, and this is the actual audio that I have used. And you can see that if you can just read, if you can understand and read Hindi, you can see that it's very similar to what I have said in the audio. So it's working pretty well for in Indian language like Hindi as well, not just for English. So if you want to incorporate or provide a voice-based input in Hindi for your application, I think you can safely use a Ministral because this is working pretty well. I mean, of course, you might need to do specific testing for your application. But yeah, I think this works pretty well for Hindi as well. So yeah, this is all we have about the Voxtral models. I hope this session was useful and I would also urge you to try it out and let me know how it works in the comments. Thank you. Thanks for watching.